Hello everyone, welcome to another video. In today's video, I want to talk about a very important interview question on Terraform, which is how to explain a Terraform-based infrastructure production pipeline in an interview. So whatever answer I'm covering here, this is from one of the companies that I have worked with myself. Okay, so I'm going to come to this theoretical part as well, but to explain this setup, I have a diagram, okay, so that you are able to understand it step by step. Okay, let's try to understand when we start to learn Terraform, how we use it on our personal laptops and what is the problem with that type of setup that it cannot be used by a company. Okay, so when we start to learn Terraform, we try to follow some YouTube videos, some blogs, some article to get started with it, right? So in general, if you're using an AWS account to create resources via Terraform in this account, what you do, you install Terraform AWS CLI on your laptop, and then on your AWS account, you create an IAM user, you generate access keys for the IAM user, then on your laptop, you run AWS configure command, you configure the access keys, and you are able to authenticate to the AWS account, and now you can run all the standard Terraform commands like Terraform init, plan, apply, refresh, validate, destroy, and so on, right? So this is good to get started with it, but if companies try to follow this approach, what will happen? So we need to understand the problem with this type of setup, and then I'll come to the real thing that the companies follow to implement a Terraform based infrastructure deployment in their project. So here, if you see, I'm just taking the example of one user, but in a company, what will happen? The same AWS account will be used by multiple people, or you can say multiple DevOps engineers. So now suppose this same AWS account is being used by two more DevOps engineers apart from you. Okay, so I'm just taking an example that you have been hired by a company and you are trying to implement the same approach that you did in your home laptop. Now you have two more engineers who are trying to get resources into this AWS account. So for them also we created two different IAM users. We generated the access keys, and then these two users have also configured the access keys, and they are able to create the resources into AWS. Now, whatever activities these three users have been doing on their laptop locally, we want a way by which we can create the versions of the activities on a Terraform based deployments to our AWS account. So I'm just taking an example. This user has done some changes on AWS account via Terraform. So he has deployed version 1 of the infrastructure configuration, and similarly this user has done v2 deployment and this user has done v3 deployment. Now if we want to roll back to the same deployment that this user or this user has done, so if we are trying to manage this locally, okay, so there's no way by which we can track these three versions. We just have the state file to look into, but we want a way by which we can track all the activities that they're doing in this version of their Terraform deployment. So what we do, we want them to do all the activity on a remote repository. Okay, here I have taken the example of a GitLab repo. This is the GitLab icon, but it can be any source code management tool. Okay, so all I'm saying is whatever activities these three engineers are doing, we want a way by which we can version them, by which we can create the versions of these three deployments on a repo which is accessible to everyone. So now in case we find some issues with this version of Terraform deployment, we want to roll it back to v2 or v1. If we can have these things versioned on a source code repository, then we can simply roll it back, okay, using the standard git commands. So this is the main reason that you cannot do the development, or you cannot use a Terraform in a company's AWS account locally. Okay, you want to do it on a remote repo, which means that whatever activities you want to do, it should be visible to others also. So we want a way by which we can by which we can push these deployment versions to a source code management repository like GitLab or GitHub or any other platform. Okay, this is I mean, this is one thing I wanted to cover here, that we want the versions of the different Terraform deployments. I hope this is clear to you. Okay. Now, how we do it in real world is what I want to explain. Okay. So this is just on the conceptual part. This is fine. Now let's come back to the theoretical part that I have already covered in one of the readme.md files here. Okay. So in an interview, how you can explain? So I'm going to cover all the things here. So the answer will be, in our setup, Terraform deployments are fully automated through Atlantis and Terragrunt. I'll come to these two terms as well. Okay, but I just want to read through and then I'm going to explain everything to you. Each environment, dev, QA, and prod, has its own Terragrunt configuration, and state files are stored in an S3 backend. Okay, developers never run Terraform apply locally. They push code to GitLab, which triggers static validation and TF-sec scans. Atlantis handles the plan and apply workflow via pull or merge request on the GitLab CI, ensuring auditability and approvals. Okay, I'll read other things as well, but let's just try to understand what I'm trying to explain here. So in a production setup, okay, I'm talking about a company where I have worked. Okay, this is the exact setup that they are following. So what they are doing, they are using a tool called Atlantis. Okay, Atlantis is a tool which can use your Terraform implementation and create a CI workflow. Okay, if I talk about the CI workflow also, let me open another window. I'll just show you what I mean. So now we know that we need the versions of the deployments. Okay, but I mean, how to do it? So to configure your and to configure your entire setup in this way, you need a tool. Okay, so the name of the tool is Atlantis, that you can use. So Atlantis is a way by which you can create a CI pipeline for your Terraform deployments as well. Okay, as you can see here. Okay, this is just a demo example, but I'm going to cover one more video where I'm going to talk about the entire end-to-end workflow with a hands-on demo. But in this video, I just want to make you explain the setup that the companies are using and how you're going to explain in the interview also. So in the interview, you're going to tell the interviewer that we have a tool called Atlantis that is used to create Terraform-based CI workflows in GitLab, like this. Okay, so as you can see, we have three stages here: validate, format, and plan. So this Atlantis tool is a way by which you can use your Terraform to create the CI workflows. Okay, but I mean, how it is doing that? So Atlantis uses another tool called Terragrunt. Okay, now what is Terragrunt? So Terragrunt is like a thin wrapper that works over your Terraform tool. Okay, I'll talk about it. The meaning of this thin wrapper is so here, yeah. So why Atlantis is using Terragrunt when we already have a Terraform with us? Okay, so why to make things complicated? Okay, so let's just understand some of the limitations of Terraform, due to which we have to use another tool called Terragrunt to overcome all the Terraform limitations. Okay, so why do we need a Terragrunt when we have a Terraform? So Terraform is your main ISC tool, which is used to write TF files. Okay, we already know that. So it's going to let you define your infrastructure as code. Okay, you can create the reproducible environments as well. You can manage your infrastructure lifecycle as well using init, plan, apply, and destroy commands. You can store the state locally or remotely as well. But when it comes to real world production setup with multiple environments, multiple modules and teams, you quickly hit challenges. Okay, why? Because there are some pain points when you use a Terraform. Okay, like you use a Terraform without any other tool. So there are some pain points around that part. Okay, let's talk about that as well, and then we'll come to how Terragrunt is able to help us resolve all those shortcomings of Terraform. So as I mentioned, Terragrunt is like a thin wrapper around Terraform that helps manage multiple Terraform modules more easily. Okay, so how it is able to do that? So think of it as a Terraform project manager, or I can also say it's like Terraform orchestrator. Okay, so it's like a Terraform orchestrator. And just like you have a container orchestrator like Kubernetes, which is able to manage hundreds of thousands of containers, okay, in a better way. So similarly, we need a Terraform orchestrator as well, which is called Terragrunt. So it's like a way by which you can centralize, manage all your modules, your Terraform files, your different environments, okay, in an easier way without repeating too many things. Okay. So how it is able to help? Let's talk about that also. But first, just remember that Terragrunt works on the principle of dry. That means don't repeat yourself principle. Okay. So if I talk about a standard Terraform folder structure, you will see something like this, that you have the main infra folder, you have some modules, and you have your main TF files, main.tf variables, data, locals, outputs, and so on. And you have the different environments like dev and prod. And within these environments, you have your TF vars files, which is defining the values of your variables that vary as per the environment. So for dev, this file is going to be different as compared to prod. Okay, you also have the different backend.tf files in general. If we talk about, so for dev you have one file called backend.tf. For prod or any other environment that you're using, you also have a backend.tf file. So if you see, there is some repetition in creating these backend.tf files. So we have multiple backend.tf files, which is like a painful thing to manage. Okay, so the first limitation with Terraform is that we have to create multiple backend.tf files to manage the state of the Terraform infrastructure configuration. Okay, and then similarly, you can, you will also have multiple provider.tf files as well as per your environment, because there there may be some variation in the dev and other environments. So you will have to create a separate provider.tf files as well in that case. Okay, so if you see here, we are trying to create multiple files of backend.tf and provider.tf files when we are using only Terraform. Okay, the third limitation with Terraform is when we are using modules. Okay, here I've just given an example. Suppose I'm using one module called VPC. Here I'm defining the source, the CIDR block, and the subnet CIDR for this VPC module. Now, if I have to use this module value with EC2 instance, then I have to manually wire everything together. Like I want to use the same CIDR from this VPC, then I have to specify something like this. Okay, so there's no way by which automatically the values can be wired together. Okay, so we need to specify these values manually. So in short, if I talk about, I'm talking about these three limitations. Okay, so Terraform with TF vars file help parameterize environments, but Terragrunt helps structure, scale, and orchestrate multi-environment, multi-module infrastructure in a better and efficient way. Okay, so if you have only one or two modules, then you can simply use a Terraform with this TF vars file. It is fine. But when you have to manage 10 plus modules across 3 environments, then Terragrunt is going to save a lot of time and the amount of mistakes that can happen while configuring the entire infrastructure. Okay, how it's going to help? So we just saw a standard Terraform folder structure. Now, if I talk about a Terragrunt-based folder structure, so this is how you're going to configure the things here. So we're going to use a file called terragrunt.hcl. Okay, so terragrunt.hcl can control the entire configuration of a particular environment in your Terraform configuration. You don't have to create a multiple backend.tf file as you were doing in your Terraform, okay, earlier on. Okay, we don't have to create any multiple backend.tf files. We don't have to create the multiple provider.tf files. Terragrunt can automatically generate backend.tf files for us. Okay, so there's some property which I'm going to talk about in my next video, where I'll be covering a hands-on demo on how to use Terragrunt and how to use, I mean, how to use a Terragrunt with CI pipeline. Okay, so I'm going to show you that as well. But just understand that a Terragrunt is a much better way when you have multiple modules, okay, multiple application that you want to deploy the infrastructure for. You have multiple different environments, so it is always better if you use a Terragrunt instead of Terraform. And this tool can be installed locally also. Just like you install Terraform, you can install Terragrunt and use all the features of it. Okay, so I'm going to come to this demo part in my next video. Okay, so in short, or in summary, how you're going to explain this to the interviewer, that we are using a fully automated tool called Atlantis, which is going to create CI workflows using Terragrunt. And we are using Terragrunt to overcome all the shortcomings of Terraform, okay, which I just spoke about in terms of the usage of modules, creation of backend files, or creation of provider configurations for all the different environments. Okay, so we can create a CI workflow like this using Atlantis, and it's going to use a Terragrunt. So Terragrunt is still going to use all the Terraform TF files only to create the resources, but it's going to manage them really well. Okay, so yeah, so this is going to be your answer. If someone asks you how you use a Terraform in production, this is how you can explain. And these two files I'm going to share across via GitHub repo link. So I'm going to put that link in the description of this video. You can download, you can go through it. And in my next video, I'm going to come up with a hands-on demo where I'll show you how to use this entire setup on your laptop, and we'll be doing a demo. So, I mean, you can also practice, and then you'll get the better understanding of this entire setup. Let us now try to understand the entire Atlantis-based GitLab CI pipeline workflow steps or stages. So as I mentioned, the engineers, it can be DevOps engineers or it can be site reliability engineers who are trying to make changes to the original Terraform files stored on a remote GitLab repo. They are going to clone the repo to their local. Then they are going to create a new branch. Then in that new branch, they're going to make the changes, and they're going to push the changes to this repo as we do in any standard Git based code. So the same thing has to be followed here also. So after they have made their changes, they're going to push the new branch itself to the main source code repo. Then they are going to raise an MR, a merge request, or sometimes it is called a pull request. So they're going to raise an MR or a merge request to merge their branch changes to the main branch or to the master branch. Okay, after that, what happens after the pipeline runs, which is to merge the branch changes to the main branch or to the master branch, you are going to see the Terraform plan output. Okay, so in the stages, in the stage section itself, when you click on the stage, you will see the logs. In those logs, you will see the output of Terraform plan, basically. So as we run Terraform plan in a local, okay, and we get some output wherein we get the details of what all resources are going to be created, modified, or destroyed. Same way, when you click on this job, you're going to see the output of Terraform plan command. Okay, if you are satisfied with that, how to run a Terraform apply here, you just, so in that output itself, you will find a new command. Okay, a new command which will be something like Atlantis apply -d, the name of the directory, then -w, the name of the workspace. Okay, so this command is like a ready to copy command that you can copy from the comment section itself after your plan stage succeeds, you just have to copy that command and paste it in the comment section in your MR. After you do that, Atlantis is going to run a Terraform apply on your behalf, and it's going to create the resources in the AWS account. So this is how simple it is to create resources via a GitLab based Atlantis pipeline. Okay, so this is what happens. Okay, as I mentioned, in my next video, I'm going to come up with a hands-on demo as well. But in this video, I just wanted to explain you the entire workflow, how it happens, so that you can explain this in the interview as well. Okay, so I hope this video was useful. If it was, please hit the like button. Please share this video with someone who has been struggling with this question or these type of questions in interviews. All right, and if you like the content, please subscribe to my channel so that it motivates me to create more videos like these in the future. All right, guys, that's all for this one, and I'm going to see you in the next one. Bye for now.